This question I discussed in the guys, and that session was little bit interrupted because of fluctuation Wi-Fi. See the sneak of this question was based on Lloyd-Max algorithm. What Lloyd-Max algorithm see that gives optimal quantizer. Okay, can design optimal quantizer, and what is the meaning of optimal here is that it minimizes the quantization error. Right. This was the result we found for the quantization level. Alpha k is equal to particular interval you have to m and the density function. This is also known as the conditional like this was the and choose interval and quantization level. So if quantization interval is given, you can find the quantization level, or if quantization level is given, quantization. This was in general discussion, right? So this result basically we have to focus. Result was this result, okay. Particular integral m probability that interval, and using this we solved this question. This question was asked in gate 2. Here the question was like, consider a real valued samples are independent and identically distributed random variable which is characterized by probability density function of x. So here this value we calculated, okay, use concept called area under the density was 1 by 2. Compute for this group, and so here the question was like, consider one bit quantizer that maps positive value to alpha. My what values we can choose for alpha? Here they have clearly mentioned. This is one of the important line which, so alpha can be taken for the positive value of x. Between 0 to 1 we can choose alpha, that is one quantization level, and beta is another quantization level, can be assigned the value from -2, because they have given others to the value alpha, right? Now if alpha star and beta star are the respective choices for alpha and beta, that minimize the mean square quantization error. Alpha minus beta star we have to find, which is one. You can see the solution. This was the density function, and about the area under the curve constant EDF got k by 2. This was function f of x, and write in particular interval. This is what the function is 1 by 4 by 2. Loop, find the slope. Loop is 1 by 4, 0 to 1. So now we can find the quantization level from the direct result which we have got from the Lloyd-Max algorithm. That is particular interval you have to integrate x dot f of x 0 to 1, okay, because we are trying to find alpha, so alpha can be taken from for positive values only. You have to choose alpha in such a way that that alpha should be 0 to 1, right? That should be positive. So this is how we calculated, and got this alpha, right? Alpha star we got 1 by 2. Now we can compute beta as well. So beta, for beta we have to choose the interval which lies between -2, right? Because in the question itself this is given that beta can belongs to. This is how we calculated, and have kept here the density function we have integrated from my. So how we solved. So here finally beta star we have got, that is -2 by 3 was the result for beta, and this is what the question is asking, like alpha star minus beta star we have to calculate by 2 -2 by 3 will get around 1.167. This was the answer for. So this question was based on Lloyd-Max algorithm. It is not discussed in any class, okay? You might have seen In fact, you might have attending various institutes where they don't talk about Lloyd Max algorithm or anything. Whenever new questions is there in the gate exam, then many educator covers these, right? So, but for gate examination must cover all the topics so that you can solve all the questions. Otherwise, you will feel that questions are very tough questions, right? These questions are not tough. You will follow the conventional approach, you will get lost in mathematics. You will lose, know will lose a lot of, I mean, you can say you will lose minutes after minutes, right? In fact, you will solve this question with 15 minutes or 20 minutes. But this question can be done with the help of Lloyd Max algorithm, and can be done so that you could save time for next question. This is the sneak peek of the solution for Lloyd Max algorithm based question. I hope you might have liked this much. We will catch up again. We will take one more new question. I will show you. In fact, I will make you surprise again. Okay, that question was asked from topic. Thank you so much.